Here is a question. If I kick a football in the middle of outer space, no air, no gravity, nothing around it, does it ever stops? Most people say yes. It slows down and eventually stops. That is completely wrong. It's fascinating that your intuition tells you that, but it's a classic physics trap. Stay with me because what I'm about to show you will change the way you see every moving object for the rest of your life. By the way, I am Dr. Zaf. I teach science the way it should have been taught the first time. No boring textbooks, just the real magic behind how the universe works. Let's go. Look at this football. If it is not moving, and here is the fascinating thing, it will never move. Not in a second, not in a million years, because there is no resultant force. As a result, it will stay still. Not unless something from the outside physically pushes it. This is the first half of Newton's first law. Objects that are at rest stay at rest. They are naturally lazy. The universe has no automatic engine that starts object moving. Something has to give them a push. The physics word for this laziness is inertia. Every object with mass has inertia. The more mass, the more inertia the object has. A football has more inertia than a tennis ball. A lorry has more inertia than a bicycle. They all resist being moved. So far, so obvious. But here is where people start going wrong. Now look at this hockey puck. I give it one nudge and then I do nothing. On smooth enough surface, with almost no friction, that puck just keep going in a straight line. Because constant speed means resultant force is equal to zero. And puck will move forever, or at least until it hits a wall. This is the second half of Newton's first law. An object in motion remains in motion at a constant velocity unless acted upon by a net external force, again called inertia. Moving objects don't actually need a constant push to keep moving. They only change, they only slow down, speed up, or turn if a new force gets in their way. On Earth, things seems to stop on their own because friction and air resistance are always pushing back. But that is not the object wanting to stop. That is an external force making it stop. Remove the external force and the object never stops. That is inertia on the other side of the coin. Now let's go one level deeper and understand why this happens. Look at this wagon being pulled at a perfectly steady speed. You are pulling forward with 50 newtons. Friction is pushing back with 50 newtons, equal and opposite. The resultant force, the winner of this invisible tug of war, is zero. And Newton's first law says zero resultant force means the state of motion cannot change. The wagon keeps moving not because you are creating the motion, but because the forces are perfectly balanced. You are not moving it, you are fighting friction, and the wagon moves. Why? Because constant velocity always means resultant force equals zero. This is where physics breaks your intuition completely. Look at these two objects. On the left, a rock sitting perfectly still on the ground. Velocity is equal to zero. On the right, a spacecraft cruising through the empty space at 10,000 meters per second. Physics says these two situations are identical. Both have a resultant force is equal to zero. Both are in what we call equilibrium. Neither is accelerating nor is changing direction. And from the universe point of view, they are the same state. This is Newton's deep insight. Force do not cause motion. Force causes a change in motion. That change in motion is what we call acceleration. Think about it. What that means. A rock on the ground needs zero energy to stay still. The spacecraft needs zero energy to keep moving. Physically, those two statements are the same sentence. That is Newton's first law at its deepest level, a statement about the fundamental nature of the universe. Motion is free. Change in motion is what caused something. Let's make this real. You are in a car traveling at 60 kilometers per hour. The driver slams the brake. Your body lurches forward. Now, here is the question almost everyone answer incorrectly. What force is pushing you forward? The answer, and this is the thing, there is no forward force. Nothing is pushing you towards the dashboard. There is no mysterious invisible hand. What is happening is pure Newton's first law. You and the car were both moving at 60 miles per hour. The brakes applied a large backward force to the car. The car slowed down, but no one applied that force to you. So, your body, obeying the law of inertia, kept moving forward at 60 kilometers per hour. You were not thrown forward. The car stopped around you. The seat belt's entire job is to be that missing force. It reaches across and provides the backward resultant force that changes your state of motion safely before you meet the dashboard personally. No seatbelt? Your inertia introduces you to the windscreen at full speed. Newton's first law does not care about your feelings. It just follows the rules. Want a proof on a larger scale imaginable? The Voyager 1 space probe was launched from the Earth in 1977. Its rocket engine were turned off decades ago. It has no fuel, no engine, no push of any kind for over 40 years. Right now, as you are watching this video, Voyager 1 is traveling at over 38,000 miles per hour through interstellar space, and nothing is making it go. Its own inertia, the inertia of a small metal object launched from a tiny planet in 1977, is carrying it through the dark forever. That is Newton's first law operating without friction, without air resistance. Object in motion, stay in motion. The universe never forgets a velocity. And finally, my favorite demonstration of inertia that you can try at home tonight. I genuinely love this one. Take a glass, put a playing card on top, balance a coin right in the center directly over the opening. Now, flick the edge of the card as fast as you can. The card flies across the room. The coin drops straight down into the glass. Why? Because the coin was at rest. It had inertia. When you flipped the card, you applied a force to the card. But the flick was so fast, so sudden, that friction between the card and the coin had no time to drag the coin along. The coin's inertia said, I am staying exactly where I am in space. The card vanished from under it, and gravity, now the only force in play, pulled the coin straight down. Newton's first law, not in a textbook, in your kitchen. Try it tonight. So, here is Newton's first law, the complete picture. An object at rest stays at rest. A moving object keeps moving in a straight line at constant speed. Neither changes unless a resultant force acts on it. The football on the grass, the hockey on a smooth ice, the wagon at constant speed, the spacecraft in deep space. All of them, every single one, is obeying the same single rule that Isaac Newton figured out 350 years ago. Forces do not cause motion. Forces cause change. If nothing is changing, nothing net is pushing. That is the whole law in one sentence. Now, I have a question for you. The Voyager probe has been moving through space for over 40 years with no engine. If a star's gravity started pulling it sideways, would Newton's first law still apply? Think about it. If this video made the law click in a way it never did before, Give us thumbs up. It tells the algorithm that more confused humans should see this. Subscribe because Newton's second law is coming. I am Dr. Zaf. See you in the next one.